Okay, today we're going to be working on the 10 penny lab, all right? Now, in the 10 penny lab, what we were trying to do, the purpose of this, is to compare two different methods of calculating volume for a penny, all right? Also, we're going to look at what advantages you get from measuring a large group of pennies, 10 pennies versus one penny. Does that give you greater accuracy in your final calculation? All right, so what we're going to do here, I'm going to click here on this. We're going to right click and we're going to delete this column. You want to delete the timestamp column now. One of the things I noticed people had in the last tutorial was that because I had deleted the timestamp and you guys hadn't, you guys had everything shifted over and you thought that you were supposed to be calculating by B when actually you're calculating by C and things like that. So make sure you delete the timestamp. All right, so we're going to do that. We don't really need that. Now, the first thing we want to do is we want to calculate the diameter of 10 pennies. We want to calculate the volume using the measurements, and then the next thing we're going to do is going to calculate the volume using displacement. So what I want to do first is I want to insert between diameter and height a column. Now that's actually a fairly simple process. You click on where it says height, and I'm going to right click and I'm going to go insert, and there's my new column, and I'm going to call this radius. Alright, so I'm going to calculate my radius. Now I'm going to make it a little squishy only because I want everything to fit on the screen, so it might be a little bit harder for you guys to read. I'm going to get rid of some of this stuff just so that it looks a little bit better for you guys. I realize that you guys are going to be looking at this on YouTube. It may not show so well. Height, I'm going to get rid of height too. I'm just going to like that so that what we wind up with having is have a little bit more room. And we're going to change this to displacement. Okay, a lot of this was necessary because I wanted to make sure you guys understood what it was you were supposed to be doing. Alright, so we got all this stuff, right? Now the first thing we need to do is we need to calculate the diameter. Well, you guys should know how to do this now. Now it's a formula, so what's the first thing you put in? We're doing my Dora Explorer impersonation. Alright, first thing you type in for a formula is equals. And then it's the diameter of 10 pennies. So I'm just going to click on the cell right in front of it. It's C2 in this case. In your case, it might be different, but you got to click on the first value in the diameter, and then we're going to divide. That's the backward slash 2, because half of the diameter is the radius, and we're just going to click that and drag that all the way down. Now, how do we get this formula to go all the way down? Each one of these cells here, you know, D3, D4, all these other guys, you want that formula to go all the way down, so you can do a relative drag through. If you click in the middle of the cell, you'll notice a white cross. When you drag it across to the lower right-hand corner, you get a black cross. When it gets to that, at the lower right-hand corner, you drag that down, and that gives you all of this all the way down. All right? So good. So now we have the radius. So what we need to do is we want to calculate the volume. So I'm going to go insert, another column, okay, right in front of displacement, because we're going to calculate volume now. Okay, now what is volume? Well, volume is pi r squared times the height. If you think about this, oh yeah, there's one other thing we do need to do here. We need to convert everything into centimeters. All right, so we really need to actually, I'm going to change the radius to centimeters. We're going to go back to this column because that's something we should have done. All right, unfortunately, remember, density is almost always calculated in centimeters, not millimeters. Of course, we measure things in millimeters. So I need to actually fix the radius and put it into centimeters. Well, the centimeters is half the number of millimeters. So what I'm going to do is first, I want to do an order of operation thing. I'm going to put C2 in parenthesis. Okay, so I got the diameter, half the diameter. I got that. And then I'm going to divide by 10. Because I want the radius in centimeters. Enter. Boom. Alright. So now, I got that one taken care of, but unfortunately I also have to fix this one because I also have to fix the diameter. So I'm going to insert, in this column, I'm going going to change volume to height in centimeters. Do the same thing here. I have to divide the height by 10 to make it centimeters. The height is currently in millimeters, thousandths. I have to change it to hundredths. So in order to do hundredths of a meter, so what I have to do is I have to divide everything by 10. So it'll equal this divided by 10. Okay. And you'll notice 14.76 becomes 1.476. And then when again, I'm going to do a relative drag fill, lower right hand corner, get a black cross, I'm going to drag it all the way down. Now I got everything in centimeters, so that's good. Alright, so now what I'm going to do is I'm going to calculate volume. I'm going to move this displacement thing over again. Okay, so I click on the top of the column, go insert, volume is the radius squared times pi times the height is the volume. Okay, that's the cylinder. So we're going to equals pi, and I'm going to open parentheses, put this in parentheses. Pi, wait a minute, 3.14 times the radius in centimeters times, and I'm going to do this the radius again. That's r squared. And then close parenthesis, and that gives me the area of the top of the cylinder, but I'm not done yet, because all that's doing is giving me the area of the top of the cylinder, so I'm going to go click back on it. Okay, with deselect, I click back on it, and now I have to go times, okay, little asterisk on the keyboard, times the height. So if you take a look at it, it's pi times radius times the height should equal the volume if we calculate, if we did our measurements right. And I'm a big dope because I multiplied by the wrong number. Okay, if you take a look here, I multiplied by the height in millimeters, and I should have multiplied by the height in centimeters, so it's not E2 in this case. In my case, it should be F2. Now guys, everybody makes mistakes. I'm expecting that you're going to make mistakes too. Alright, so you get the height in centimeters, the radius in centimeters. That's what you need to do. You need to be using. So we should have both of them. Alright, so now I'm just going to drag this down, and that looks more correct. Okay. Okay, now I made the mistake. I didn't drag down, when I converted radius into centimeters, I didn't drag that all the way down either. Alright, so that looks a little bit more like it. Alright, so now you notice everything's in about the 4.1, 3.9 phase. Okay, so again, I still haven't calculated density, because what I need to do now is I'm going to hit Insert, Density, and this is density using measurements. So in other words, this is how we calculated density when we did measurements. Okay, so this is going to be equals the mass, in this case 26.9 grams, divided by the volume that I just calculated. Boom. And that gives me 6.49. And then I'm going to drag this all the way down. And I'm going to do that for all of them. There we go. So there it is. There we have it. Now, it looks like some of these numbers are getting a little messed up, so we're probably going to want to take another quick look at them, see if we can figure out what's going on here. Oh, I know what the problem is. I didn't drag these up. This is a pretty big spreadsheet, and I didn't drag the formulas all the way down. Now things are getting a little bit better. All right. Now, there's one other quick thing I want you to notice. You notice somebody here wrote in the label. If you take the label off, everything will pop in. All you have to do is delete that label, and it'll work out fine. All right. So, there we go. All right, so that's displacement density with measurements. Let's do density with displacement. If you calculate the volume displacement. So we're going to do that. So this equals weight, which is still 26.9 grams, divided by the displacement. Now, in this case, the volume, if you calculate the volume with the amount of water displaces, okay, that gives you actually a different number. All right. Now, I'm actually looking at these numbers. I'm not really crazy about what I'm seeing here. Looks like people had some pretty inaccurate measurements. All right. But if you actually take a look at it, let's just hit enter, and then just drag this all the way down. All right. How much water was displaced? All right. Now, again, whenever you see something like value, it means somebody threw a label. You have to get rid of that. All right. So if you actually take a look at this density measure here is 6.4. This one here is 5.3. Blah, 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 blah. They're not too far off. Okay. I mean, some of them are horrible, and some of them are pretty good. So let's see if we can figure out what's going on and how this compares to the actual measurements that we're looking at. All right. In other words, how does this compare to what we know to be the mass of coins?